Welcome to this MLOC group webinar. If you don't already know, MLOC stands for Million Lines of Code. We are an open and agnostic community that focuses on the challenges that come along with developing, deploying, and managing some of the biggest applications in the world. And you can find us at mlocgroup.com. That's MLOC. We've been hosting a series of webinars, but we're also going to be scheduling and organizing some local in-person events very soon. We're actually looking at doing something in New York City, either later this month or early next month. So keep an eye out for that as well. If you'd like us to come do an MLOC group event in your area, just let us know, and we'd love to try to organize something near you as well. Today is the 10th of February. I'm Jim Schultz. I'm the head of community at MLOC Group. Today, our talk is going to be given by my old friend, Nicolas Chaillan, and he is a CTO at Prevent Breach and former Chief Software Officer at the Department of Defense. And his talk today is all about DevSecOps transformation at the DoD. Before we get started, though, I do want to acknowledge and thank MLOC Group's corporate sponsor, which is Incredibuild. As soon as I'm done talking, I'll post a quick link to Incredibuild in the chat. I'm also the head of community at Incredibuild as my full-time job. They've been really great in fully sponsoring me with this MLOC Group initiative that I wanted to start. So Incredibuild works, if you don't know what they do, they work with a lot of really big companies that have big applications and helping them reduce their build and release times. Most importantly, when we do in-person events, we just did a big party at CPPCon a few months back. They pay for all the food and drink. So I want to give a huge shout out and thanks to Incredibuild for all that. Like I said, if you have any questions during Nick's talk, please feel free to drop them into the chat. Nick is going to pause a few times as well if you want to come off mute and ask questions. The talk is about 30 minutes or so, and then we'll have some open Q&A and group discussion at the end. So it is now my great pleasure to introduce Nick. Nick, if you want to take a second to introduce yourself before your presentation, and I'm going to go ahead and pass the virtual mic over to you.
Sounds good. Thank you so much for having me. I'm excited to be able to share some of the journey of the Department of Defense moving to DevSecOps. But there's a little bit of background. As you can tell with my French accent, I was not born in the US. I came from France. Moved to the US about 11 years ago. I created my first company back in France. I was 15, I'm 37 now. So I've been an entrepreneur for 22 years. I founded and sold 12 companies. So I'm lucky enough not to have to work anymore, which is always fun. And I was able to go first at DHS, be the chief architect and special advisor for cyber 5 years ago, pushing zero trust to DHS. And now, last 3 years, I just left 5 months ago, the DoD, where I founded the DevSecOps initiative, and I became the first chief software officer in the US government, pushed enterprise DevSecOps and moved the behemoth that is DoD to Agile and DevSecOps best practices. So I wanted to share a little bit of some of the journey. First, I have a couple of links. If you want to take a screenshot or look at the recording, some of these links, there's a lot of curated content. I'm always very cautious not to push for any cloud provider or any product. So it's curated to be as much as we can unbiased to a company. And we also have the In the Nick of Time event on LinkedIn. Every other Tuesday, I have guests coming talk to us about what they're working on in the Department of Defense or the US government, innovation, DevSecOps, cloud, data, pretty significant senior executives joining. In the next couple of weeks, we're going to get the Air Force and Space Force, the CIO. We had the new DoD CSO. So we have always pretty fun guests join and talk to us about what they're working on. And we also have a lot of content in terms of architecture documents and the whole source code of what we built. We open source most of the code. So if you want to check out software.av.mil, you're going to find there all of the documents and all the architecture documents and the link to repo 1, which is the source code repo of the DevSecOps initiative at repo1.dso.mil. So if you have not heard about the DoD Enterprise DevSecOps initiative, we created it as a joint team across the department. As you know, DoD is the largest organization on the planet. We wanted to bring tangible outcomes, not just governance. So we created enterprise capabilities that bring options and diversity of options, but at the same time, create a cohesive cyber stack to be able to move to zero trust. So we created Cloud One, which is a cloud office with both Amazon, Google, Microsoft, and others, and Oracle. And the Platform One, which is the DevSecOps teams, and we'll show you how we kind of cut it and how that made sense. The main goal was to bring enterprise scale for the DevSecOps, but also avoiding vendor lock-in to a cloud provider or to a DevSecOps platform. So we use Kubernetes and containers to be able to have these reusable Lego blocks. So you'll see that as well. We created these managed services with collaboration tools, development tools, cyber tools. We created Iron Bank, which is the DoD centralized artifact repo, kind of a Docker hub of DoD, more secure. We harden and scan and update open source and commercial products, 950 containers now. That's public, anyone can consume these containers. So we have many companies and agencies outside of DoD and even nations outside of the US partners using Iron Bank for their container repo. So that's awesome. We integrated and baked in zero trust into the stack. So we'll talk about some of the behavior detection, moving target defense, and zero trust down to the container or the function level. And we had 100,000 people to train a year, so we had to bring unbiased self-learning training curriculums. So we partnered with the Linux Foundation, O'Reilly, the books, the publisher, to bring some of the best of breed DevSecOps, machine learning, AI, agile training there is. So I'm pretty excited. We gave an hour a day to our people to learn and be able to do it continuously and not just once a year because of the crazy pace of IT right now. So why does DevSecOps matter? Well, first, if you have to compete, the timeliness aspect is obviously essential. Fail fast, learn fast, but don't fail twice for the same reason. Small incremental delivery of software, so you're not breaking things and falling down and not be able to stand back up. Of course, China and Russia are massively adopting DevSecOps, so we don't want to be left behind. And it's really what gives us the foundation of velocity for cloud and software innovation and AI, ML, and scale. We saved in 1 year moving to DevSecOps with 27 DoD programs. We saved 100 years of time. 100 years of time that we saved allegedly, although I would argue we just didn't we didn't waste it. Because obviously I would argue it's something that wasn't really needed. So I don't know if we saved it or if we didn't lose it, but waste it. But either way, I think it's important to see the impact of the timeliness there. We have a concept in DoD called authority to operate, where we accredit software. We created the concept of continuous ATO, which saved about 12 to 18 months of time per program per 5-year cycle. We also saved 4 to 18 months actually already now, thanks to the continuous feedback loop with the warfighter to see what features was sticking or not, what changes we should make by continuously delivering small incremental changes in production. And we ended up saving, like I said, 4 to 18 months of time per program per 5-year cycle. And of course, saved a bunch of money per program per year, 12.5 million per program, but also the time is not valued here. So there's obviously a cost of that time that we saved. So, but that's not included in the 12.5 million. We brought hardware in the loop testing capabilities. So we'll show you a little bit what that looks like when you have embedded hardware. And we did it for the largest weapon systems on the planet. We're talking jets, bombers, space systems, nuclear systems as well. So this is not just mobile apps, okay? This is real stuff. So some of the numbers that we got out of that was pretty amazing. As you can see, we got 106 times faster lead time from development to production. 208 more frequent code deployments, 7 times less failure, 22% less time spent on rework or work, unplanned work, 50% less time spent on cyber issues, a mind-boggling 2,600 times faster recovery, which obviously is particularly important for weapon systems to recover after issues. And we saw a 40% decrease of development costs, which effectively enables us to do 40% more with the same amount of money. And a 2.2 times more likely for employees to recommend the organization, which was both a great capability to retain and attract new talent as well. So that's pretty mind-boggling as well. So obviously, that's significant when you look at a tangible use case, because that usually helps people understand a little bit the impact here. If you compare SpaceX that's using DevSecOps to F-35 that was not using DevSecOps yet, as you can see, SpaceX has 9 platforms, vehicles, F-35 has 1 with variants. SpaceX has 200 developers, F-35 has 4,000. The defect rates of code at F-35 was 50%. So effectively, we had 2,000 developers useless. And then, if you look at the reuse, 80% of the code between SpaceX is reused between the 9 vehicles because it's very modular and containerized and Lego blocks type. So you can swap a few Lego blocks and create a new platform. Versus F-35 that only had 4% really of code shared between F-35 and F-22s. So most of the time was a complete rewrite, despite the fact that many things could have been reused. And by cutting the monolithic software into microservices or containers, that could have helped do that. Of course, SpaceX can do updates, software update the day before the launch versus an average of 1 to 7 years ready at F-35. SpaceX can do 17,000 build of software a day and 3 hardware in the loop testing a day. So they can test the changes on the actual hardware to make sure it's not breaking anything. And everything is containerized and Lego block capable versus F-35 is just not capable of doing that at all. So that was kind of the breadth of impact of not using DevSecOps best practices, and really kind of the only way to build software in 2022. When you look at what we did in 2019, we took the F-16 jets and we put Kubernetes and Istio, the service mesh, in 45 days on the legacy hardware on the jet, and deployed Java and Go and Python containers on something that used to run Ada and C on the same hardware without swapping the hardware. And then in 2020, 2021, Kubernetes and Istio became the default for Air Force and Space Force programs. And we took a platform like the U2, which is a 60 years old platform, and we put the platform 1 platform, DevSecOps platform, on the jet in 12 days. We built AI/ML containers that would be able to manipulate the sensors of the jet so the pilots don't have to do that anymore. And we were able to deploy that on the jet in 12 days, fly the jet, and demonstrate we could receive over-the-air updates while flying with no impact to the airworthiness of the jet, and be able to update the AI/ML containers so they could continuously evolve and improve without impacting the flight control side of the aircraft. So decoupling the flight control from the AI/ML or the new kind of innovation side of the house. That was very impactful, obviously, kind of a Tesla model of being able to have a piece of hardware that's stale, but the software continuously evolving despite being stuck in time when it comes to the hardware. So I guess I'm going to pause here and see if we have any questions.
Feel free to come off of mute. There's no questions in the chat right now, Nick, but if anyone would like to come off of mute to ask any questions, feel free. Give just a minute here. All right, no takers yet.
All right, let me know. Cool. So we decided to be efficient and cutting the layers of infrastructure and platform and application So a lot of the cyber controls and the orchestration could be automated across teams, so we don't have to have issues when it comes to deployments and disparity of cybersecurity stacks. So the infrastructure layer could be a cloud, could be on a classified cloud air gapped, could be a weapon system, could be on premise at the edge, could be pretty much a little bit of anything. We put the platform layer on top, so that's Kubernetes. We have multiple distros on top of Kubernetes that give a lot of options, whether it's a Red Hat OpenShift or a Rancher RKE or K3S or AKS, EKS, or Day2IQ Convoy. Lots of different options we could use, but yet the same API, same abstraction, so we're not getting locked into any of these providers. On top of that, we put the continuous integration, continuous delivery pipeline that's fully containerized. We'll talk about that. So the entire CI/CD pipeline runs on top, and we have a lot of diversity. 16 programming languages, 23 databases, 950 plus tools that could be leveraged. So giving a lot of options to people, despite having the same orchestration, teams would be able to customize all that stack based on their needs. Very important for an enterprise service to have kind of a breadth of diversity. So we're not getting people to be limited in their options. So, and then the service mesh on top, that's doing the zero trust enforcement and whitelisting traffic. Container A to talk to B has to be whitelisted. We use Istio. And as you see on the left side, the continuous monitoring side is using what we call a sidecar container to be able to inject all the cyber visibility and enforcement we have to be able to monitor the runtime, the logs, the telemetry, and the behavior of the containers and the CVEs, and proactively kill containers every 4 hours to go back to mutable state, creating a kind of a moving target defense, and really bringing a lot of baked-in enforcement across the stack by being decoupled as a service mesh. Is running as a sidecar container, so effectively it's not embedded inside of the container. So if you need to update the cyber stack, I can update the sidecar container without updating or reaching out to all the development teams to update their containers. It's a separate containers that can be updated without impact to the rest of the mission software. So decoupling the cyber stack from the production stack is obviously critical as well. And then on top of that, you put the
I'm sorry, there are a couple of questions in the chat here.
Okay.
Do you mind and these are somewhat related too, so I'll just read them both to you.
Yeah, go for it.
The first was about how do decisions on having Kubernetes and Istio come into effect for such varied hardware? What was the decision-making process like? Interested from a management buy-in perspective. And then the other question was if you had any culture issues moving over to a DevOps model.
Yes. So when it comes to picking Kubernetes and Istio, at the time there was still a big fight between PCF, Cloud Foundry, and Kubernetes, but my opinion was that Kubernetes was going to win, and so it happens. It won, and so I pushed that decision with the leadership, and they listened to me, I guess. And in terms of buy-in, I think we used some of the largest organizations on the planet that were already moving to DevSecOps and Kubernetes, and kind of used them as a good case study. And honestly, I guess they just listened to me. So it took a lot of convincing. Took probably 6 months for people to understand that a container was not a shipping container, that I wasn't trying to ship stuff to Afghanistan. And once the people started to understand what a container was, I think things got easier and easier, and we started to deploy a couple of use cases. We did the F16 pilot, and once people started to see the cyber benefits, the orchestration benefit, the timeliness, accreditation benefits, and all these carrots, I think people got pretty excited pretty quick. So that's one. When it comes to culture, obviously 4 million employees. I would argue we still have culture issues. None of it is solved. But I think the key was to show some of the numbers I showed you before, and the shift left is always a very tough thing to achieve because we have so many silos. We have operational testing and integration testing teams, and we have cyber teams, and everything is decoupled and linear and very siloed. And so convincing people to be embedded and shifting people left was a tough thing. And it took a lot of training. That's why we created a lot of agile executive leadership briefings, and I spent kind of 3 years of my life talking to people to educate them. And then of course I had a pretty significant team to help me as well. So and I guess I see a question on Iron Bank container, all the image already stigged. Can any group use them? And the answer is yes, it's already stigged, and yes, anyone can use them. So that's why we have 12 agencies outside of DoD, 5 nations outside of the US using Iron Bank. We have dozens of companies contributing and using the containers. So it's pretty exciting to see. Do you want to do more questions, or you want me to go back to the slides?
I was gonna recommend maybe we continue through the presentation, and then we'll save these questions. We will get to all of these though.
Yeah. So when we moved to the layer approach, we also looked at an example of a pipeline here, as you can see, pretty basic but complex still. A lot of different tools. It's just an example. We have 950 containers, so there's much more options, but it's just an example of a pipeline. When you have this running on dev and test and staging and prod across multiple classification levels, you're gonna have drifts if you're gonna run all these stuff on virtual machines. It's gonna be very tough to maintain and update. By moving all of these as containers, we would have a capability that would kill the container every 4 hours to go back to immutable state with no impact to the runtime, and be able to self-update, self-heal when there's crash, always staying up to date and having that kind of baked-in enforcement. So already running as a container and GitOps and everything as code, infrastructure as code, configuration as code. So there's no drift between classification level was so important. So that was very helpful. That led us, kind of as to why we pick Kubernetes. We talk about the avoidance of vendor lock-in and the fact that containers are mutable, so we can centrally accredit them and harden them. That's kind of what people try to do this with VMs, but the fact is virtual machine images we're not compatible across cloud providers, so you have to have a different image for Azure and vSphere and Amazon and so on, versus the container could run anywhere. So that was a massive enabler of reuse of the Lego blocks. And, of course, Kubernetes bring that resiliency with the self-healing of containers, the automated injection of the sidecar to be able to enforce zero trust, and decoupling the zero trust stack, which is so important, because if you have to reach out to 900 teams to tell them, hey, you have to update these cyber bits, that creates a massive lift. When we can run this as a sidecar that can effectively be updated independently to the mission container, and gives a lot of freedom for us to make changes. So that was always awesome. And of course, thanks to infrastructure as code and GitOps, everything is automated, push button deployment, and auto scaling up and down based on memory and compute needs. That's awesome as well. So I guess the service mesh was kind of the next step for us. We picked Istio and Envoy as a proxy, really bring decoupling a lot of different things. It's not just the zero trust layer with the mutual TLS tunnel enforcement. It's also the API management, service discovery, authentication, all the routing, A/B testing, canary releases, observability. All these things are now decoupled and can work across programming languages. So if you have teams using different languages, and we support 16, it would be very painful to give libraries and tell each team, hey, you have to update that library thing for your API authentication or API management, service discovery, or routing, or east-west traffic management. So by having as a sidecar And that avoids a lot of friction between the teams and dependencies and bottlenecks, and streamlines the updating of the cyber stack and the mesh. So that was game changer. When people get used to the mesh and what you can do with the mesh, it's much more than just east-west traffic and egress and zero trust. It's really enabling a lot of the fault injection and observability and A/B testing and gradual rollouts and all that stuff. So very good kind of capability for teams that are getting used to writing microservices. I would argue trying to build a complex application microservice based without a service mesh is probably a non-starter in 2022. So that's kind of a must. And then a couple of slides before we take more questions. The infrastructure as code was an essential pillar of the stack. No human making change in production, everything in code, no drift between environments, immutable, replicable, automated, reducing the attack surface by disabling all the ports and inside a thread because there is no human in production. Every change will be made in Git and have required a multiple set of eyes to be approved. So not one person could approve a change. Everything is code, including documentation and networking and tests and cyber firewall rules and whitelisting and stuff. So everything is code. And that kind of helped us move to the GitOps, which is kind of the same concept on steroids, where everything is code. You can check your desired state in Git and have a full auditability and compliance and see your desired state in real time, roll back if you have issues, consistent deployments, change management enforcement, because everything is in Git. Everything is a change, is a merge request or pull request with multiple set of eyes to approve it. So that's now your change management bold process. Disaster recovery is streamlined. All you got to back up is your databases and your Git repo. And you can go back in time and even see what was the state of your system a year ago or 5 months ago or whatever. And it's a pull and not a push. So what I mean by that is a lot of people using CI/CD pipelines make the mistake to allow the CI/CD tools to push to production, which means the CI/CD pipeline has the keys to the production clusters. In our case, it's the opposite. The production system pulls from Git and deploys to production automatically. So it's going to check every minute, see if there is a Git change and apply it in production continuously. Everything is declarative, manifest and playbooks. Everything is code. And we used mostly Flux, but a little bit of Argo CD as well. And all of the two projects are part of the Cloud Native Computing Foundation, CNCF. So I'm going to pause here. I see we have a couple of questions. I guess I could take the sidecar question. Do you worry on that leaning on sidecars could be impactful to performance and scaling? So we use kind of both what we call daemon set and sidecars. Daemon set is at the node layer, and sidecars are the container layer. And there is some impact. It's about 5%. When you compare to the benefit of decoupling the cyber stack from the application mission software, it's a no-brainer. So we even on very limited hardware, being able to move to zero trust and enforce zero trust and have the reverse proxy to do a lot of the detection and the prevention of the traffic and the east-west traffic and north-south traffic. That's just such a massive impact, and honestly, for the 5% performance that we saw, that was not a big deal. So we managed to do it on jets and bombers that were 60 years old, so without changing the hardware. So there's that. Did you purchase a tool to capture those reporting metrics and time saving, or is it an in-house one? Example, lead time to change. Yeah, so we built something in-house for the DORA metrics, right? So mean time to production, mean time to recovery, all the key metrics. We open source most of it. It was based on top of an open source tool that we had to customize, make deep integrations to GitLab and to Jira, so we could have the tickets, so we would track both the commits in Git, and kind of the time it would take to solve the tickets and track the recovery and all that stuff. So if you're interested, you can shoot us an email, and I can put you in touch with the team that's building that capability as well. I see Danny saying when something like Log4j comes out and your virus definition gets updated, is everything in the CATO program 900 plus containers and everything else from prod to dev rescanned, and if something falls out of compliance because of that, what happens? Yeah, so that's kind of the benefit of Iron Bank and the containers, right? So first, when Log4j happened, we had multiple options. One, we use a daemon set on Kubernetes to force hot patch all the Java containers running on the stack. So we could run a container that would just scan all the containers and hot patch Log4j updates without waiting for each team to do their updates. So we had that ability because of the centralized orchestration. Despite the fact that we had hundreds of clusters running in our gap system, we could inject that new container and have it running on every node of every cluster and hot patch all of the existing containers. That's one. Two, of course, thanks to the layer in containers, if there's a CV at the OS layer or at the Java layer, since a Java app would use a Java container, if we update the Java container, then all the Java app self-update. So like we had CVs on TLS bits or Linux, RHEL base OS. We could just update this one image and all 950 images self-update, which is pretty game-changing. Most of the CVs are usually at the OS layer and the dependency layer first. There's obviously more, but that gives us a massive ability to update across all these 950 products, including commercial products. So the beauty there is that we convinced 250 companies to use our base image for their containers that's tagged and based on a UBI, universal base image, which is based on RHEL 8, but free, no cost. So those companies could swap to UBI, and then if there was a Linux CV, we could update it, and they wouldn't have to worry about it. And that would really give us a massive amount of flexibility and timeliness when it came to updating CVEs. So now if a team has a CV and is not updating it, there's timelines by which they have to remedy the finding. And if they don't, we DATO, so we remove the container, we kill the container, and then it's marked as not being able to run. And then we have an admission controller on Kubernetes that will just kill it and not let it run. So that's obviously the worst case scenario once people fail to do their jobs. So hopefully that answers that. All right, I'm gonna go a couple of more slides, and I have 4 more slides. So
thanks, Nick. Well, by the way,
yeah.
Just want to make a quick announcement that all the links that you're sharing and stuff too, if you can send those to me afterwards, I'll put those into the description.
I'll send you the deck. Yeah, I'll send you the deck.
I also put the link in the chat for the YouTube channel. This video will be put up there early next week, so keep an eye for that. All right, sorry, Nick. Thanks.
Not a problem. So when you build an enterprise service of that scale, you have people's egos, silos, and whatnot. Very large organization. You want to bring diversity of options. You don't want to bring a one size fits all, but there are things where you want to have 50 options. Some things you want to have 2 or 3, and some things you only need 1. When it comes to identity management or zero trust stacks, policy enforcement point, all these things is probably better if you only have 1, because you're going to have a lot of integration, a lot of nightmares when it comes to zero trust. So we brought a single sign-on stack, and for both person entity and non-person entity, we built a lot of kind of opinionated, I guess, capabilities when it comes to the mandated stuff, but then we were very flexible when it came to all the other stuff. So very important as an organization to decide what should be opinionated, what should not. That's critical. And then we built some enterprise services. Some were free, some pay to use. Repo 1 is a source code repo. We have all the source code of all the hardening of the distros, all the containers, and all the code, and all that open source stuff is there on Repo 1. And then we have Iron Bank, which is the containers, where you have the 1,000 now containers signed and hardened and good to go. Of course, if it's a commercial product, people have to buy the license of it. It's not magical, but at least the container is ready to go and already approved for DoD use. And then Party Bus is our multi-tenant. So effectively, we have Platform One Big Bang, which is the Platform One platform, DevSecOps platform that runs both in dev and production, right? Because it's going to do the enforcement, the zero trust, the continuous monitoring, runtime, behavior detection, all that stuff. So don't think Big Bang is just a dev thing. It's a production thing as well. And so Big Bang is open source, and we have dozens of companies using it outside of DoD, and companies like Lockheed announced they're going to use Big Bang for all of Lockheed, including non-DoD work. So we have a lot of people using Big Bang, including 5 nations and so on. So we open source that, and we have a massive number of contributors outside of DoD now contributing code back to Big Bang. And then we have Party Bus, right, which is effectively our hosted kind of SaaS version of Big Bang, multi-tenant, that we host for DoD. But so many programs want to have their own dedicated instance, so they can take Big Bang and deploy it on their cloud or air-gapped or whatever environment they use and run with it. Or they can use the multi-tenant, pay-per-use hosted version. So it gives a lot of flexibility for people to do that. And then we built a pretty significant training curriculum. We gave an hour a day for our people to learn. We created a lot of content with the Linux Foundation, CNCF, and O'Reilly, the publisher, and we created the workshops and courses and really trying to help teams with the adoption of DevSecOps and Agile in general. So that was obviously a critical component. Since we had 100,000 people, we had to train a year. So all right, that was the last slide, so we can go back to questions. Do you want to ask the question, or you want me to read them?
Yeah, go ahead. I just have a quick question. Maybe I can ask you this now too. The slides, are you going to be able to share the slides too, or?
Yeah, I'll send you the slides.
Okay, perfect. So yeah, I'll have that up with the video, everybody, up on the website once I get that from Nick. Yep,
I'll send it right after the call. All right, so someone was asking about hiring and retaining in the cleared space has been increasingly competitive. As the need for cleared resource impacted your hiring requirements? So yes, but at the same time, we're trying to do, we're trying not to overclassify and trying to do as much as we can in class and push up. And so definitely, people that just focus on the clearance and forget about skills and training and investing in people and just see people as a way to make a quick buck, that's just not going to work anymore, because people are going to move to organizations that have a culture and see beyond just a top secret or secret clearance or whatnot. So I think it's very important to invest in people. We're giving an hour a day to people both on the government side and the contractors in the team for them to go and learn. The clearance process is doing a little bit better, but still painful. But we managed to also take people that had no expertise in DevSecOps, and within a couple of years get them where they needed to be. So there's kind of this whole curriculum, and there's a lot of Linux Foundation certifications now on Kubernetes and different things that really are very good. It's not the usual certification like in cyber where you can just read a book and pretend you're a cyber guy. These are hands-on certifications that really are very good to assess someone expertise. So I love those a lot. So so Patrick was saying, my thoughts on pathways for integrating micro devices that could exist on the boundary edge, specifically to get data securely, authoritatively collected from the micro edge, so it can be integrated with the other data collected via the normal pod Kubernetes app collected data. So we had a couple of use cases in space, particularly where we have very limited footprint. We managed to still deploy K3S on those, They might not be as micro as what you're describing. I don't know, but they were pretty light, and yet we were able to run K3s on very minimal hardware, and be able to connect it to the mesh and push it. Otherwise, we do have a capability with a mesh where we could still, depending on the hardware and the complexity, but we could still run on ARM processors or non-x86 compute. We could run the proxy to be able to connect it via zero trust to the rest of the system. I think my only fear is if you start bringing a completely different orchestration, is how do you enforce the zero trust mindset? And if you have a weak link that does not have zero trust and you just whitelist the traffic, that's probably your weak entry point for a malicious actor to get into the rest of the system. So that's something to think about. But I guess it depends by what you mean by micro. Some people have different perspectives on that. But what we managed to do with K3s on very small hardware, that was pretty mind-boggling. So tiny footprint and tiny compute and memory as well. So let's see. What is my view on application security posture management? And in my opinion, what would ASPM mean to you? I've honestly never heard the term ASPM. So I guess I don't know. I never heard that term before. Posture management, I don't know. Sorry, maybe if you tell me more what that entails and what kind of applications would fit in that ASPM category, I guess I could answer the question.
Hi, Nicolas.
Yes.
I'm here. So I'd like to quickly introduce myself. I'm a founder of a startup based out of Australia, as well as a consultant. So day-to-day job, I helped clients to start their journey with DevSecOps. On pretty much in the night or whenever I'm pretty much not sleeping is where I work on, or attempting to work on, I should say, on application security posture management. The idea there is to somehow bridge the gap between what typical right-wing application security folks would start out, which is we want to do threat modeling, we want to put in security requirements, and then we have developers who are working on, hey, this is what we need to solve for the business per se. And the gap is the unfulfilled security requirements. So how can an organization actually track which requirements are we not fulfilling? And how can we smartly enable this backlog? Instead of telling we need to fulfill 100 requirements, the idea is to bring about a much more formal way saying, this is where we lack in terms of governance. This is where we lack in terms of, say, the potential attacks that could be realized. And also mapping back to SecOps language, where we talk about specific techniques and tactics or procedures that could actually be realized. So the idea is to attempt 3 different worlds: security operations, typical left-winged or right-wing application security folks, and developers onto the same page.
No, I get it. No, that makes sense. I guess I never heard the term, but I get the concept of it. So we're using actually a couple of applications in DoD to do that. Most of the teams that I know use a product called SD Elements, which is effectively kind of based on the type of applications you're building and your cyber posture and the current state of the application is mapping back to NIST 853 controls and kind of trying to point the gaps and tell you, which one are more important and creating tickets in Jira and stuff to be able to do it. And then you have deadlines to be able to be compliant. And that impact your ATO if you're not. Some controls are a must, some are, can be waived, or you can have some time to fix it. And it's kind of using a mix of scanning plus developer reporting things and the cyber team and of course all mapped to NIST. I know there are others, right? Armor code and whatever other applications do stuff like that. sometimes I find some of these applications to be too focused on compliance and not actual security. So I think that's kind of the key for me, is to see really how do we realize that applications have dependencies and the software bill of material, and we pretend we check that control, but did we really do it in full, or is it just a piece of it because maybe we have dependencies that are not compliant with it and we don't even know because we use 500 dependencies of different things. So it's always a tough thing, right? And the more we move to microservices and containers, and the more we have dependencies and SBOMs, the more we're going to find gaps. And at least with Iron Bank, we provide a full bill of materials with the findings and CVs of the dependencies and the containers. And that let us at least be aware that, hey, this container uses log4j or whatever, right? And that's massive value. So I think what's important to me is to make sure we don't waste a bunch of time on just compliance things that are not directly tied to cyber outcomes. Hopefully that makes sense.
Yep.
All right, so I see Vincent was asking about the memo from David Amaki on the DoD CISO on Continuous ATO. So I wrote the memo, but I wanted to make it clear that they added a little sentence that got me a little upset when they added that all Continuous ATOs would have to be approved by the DoD CIO shop. And that's just a giant mistake and a massive bottleneck, particularly when the DoD CIO has never approved a single ATO, Continuous ATO before. So I find that to be very short-sighted. And that's another good example of a very good idea that turns into a bureaucracy debacle, often driven by egos. So that's not great. So your question was, what else needs to happen across the DoD for advancement and broader adoption of secure software development? There's still a lot of gap of funding, basic funding of basic things, but honestly, there's just so much reuse and reinventing the wheel, with the Army rebuilding their own factory in a vacuum without using any of the platform on stuff. And there's just a lot of waste. And we don't have the talent or the luxury of time. And China is not making that mistake. And it's just mind-boggling to me how much money is spent for the same things. You look at ABMS and project convergence and overmatch, and then we pretend we're doing this joint all-domain control, command and control, JADC2 project, supposedly connecting all the weapons together. And yet we let the services do whatever they want in a vacuum and pretend it's all going to magically connect through APIs. And it's just a pipe dream. APIs is not the end of it all. If you look at my SpaceX example, it's not just APIs, right? It's these Lego blocks, these 80% code that can be reused, or containers that can be shared across teams. If they just had APIs, most people would have rebuilt the container, because just consuming an API is not enough. They want to be able to have the actual capability running on their stack. And so it's really more about sharing these artifacts and making them available. People keep talking about APIs like we're going to connect everything together, which is a massive cyber risk, but it's also not realistic whatsoever. So I think talking more about sharing code and containers as Lego blocks across teams, that's a better outcome. So we need to enable that by starting to mount a merger of some of the top talent in DoD and stop this kind of bleeding of talent and waste of taxpayer money. Until we do that, it's only going to be anecdotal progress. So
as a follow-on, no, thanks. That's a great answer, Nick, and I appreciate it. But as a follow-on, there's a call for more and more DoD software factories. You have a whole map. I remember yours. Our software factory is on there too, N2X.
Yeah.
But broadly, right? Is there going to be an initiative to do that unification? So there's the less diversification and duplicity of effort, and just kind of more using it the whole, right? The strength.
Yeah, no, I get what you're saying. So there's two sides to this, right? And we have to be careful, right? It has to be very done right. The issue is I give a lot of advice to the leadership, and then they do it half-baked, and then we turn it into a disaster, So I'm trying to be more and more precise to avoid that kind of stuff. But so in this use case, it's very important to make sure software factories are not reinventing the DevSecOps platform, right? So my take is, and look, if platform one doesn't win, I don't care, but there should be like really an investment made into a platform team with a service mesh and really done right. and merging the talent and enabling that. Not every factory should build a platform from scratch. That makes no sense. They should pick the tools and maybe have their own pipelines and customize the platform, but they shouldn't build it and run the entire stuff from scratch, right? So first is defining what a software factory is. For me, people like Platform One should be kind of the people building the factory, and then people building mission software or software factories that just build mission software. They don't build the foundation, right, of the factory. That's the first step. Second step is to make sure that each software factory has a very clear set of objectives and things they're supposed to be working on. Right now, it's not really the case. You have a lot of factories coming up and doing a bunch of different things with no clear objectives, which means really no one knows where to go, who to talk to when it comes to different things in space or in Navy stuff. So it's so broad and vague and half-baked that there's just no mission statement, right? We should have a very clear mission statement per factory. And if there's two factories with competing mission statements, they should be merged, or they should be very well clarified to avoid building the same things 20 times. That's what's, everybody in DoD used the example of Amazon and Netflix, right? But they forget that Amazon and Netflix did that, right? They give a lot of freedom for people to pick the tools they want to use, but they still have to use the same kind of cloud and the same orchestration ICAM and SSO, and it's not like free for all. You do whatever you want, and more importantly, they have a very clear mission statement. So no two teams will be building competing microservices. So it's just important we don't have that. I think we need to solve that. And I'm against like merging factories just for the sake of merging them, unless they are redundant, right? Hopefully that makes sense.
Thanks.
So Danny was asking what would be the process for lift and shift versus building a new application on top of Platform One. Where is the getting started guide? So we have training, but honestly, we grew so fast that it was tough, right? A lot of people didn't get the right training to help people get there. My office used to be that, but now we don't have a CSO yet. They're looking for one, but we don't have one. So it's been tough. What I used to do is we had a training on the strangler pattern, right, to explain to people. And I have a whole video on the software.dev.mil website on how to strangle a legacy to move it to DevSecOps. And there's a very clear process. It's not the usual nonsense of 3-year refactoring before we start delivering stuff. It's more incremental delivery while improving so the end user sees progress. If you start just refactoring without improving, you just people get frustrated and Congress ends up pulling your funding. So I think it's very important to do it right. There's some good training out there, but it's also very difficult for some of the legacy use cases. And that's where I used to be pretty good, because I would be able to sit down with the programs and go deep in the tech and see what could be the best way. Obviously, you're not going to have the same process if it's a web app versus an ADA embedded system thing, right? So but it's doable. I mean, we've done it with U2 and F-16 stuff, and if we can do it with 60 years old hardware without swapping the hardware, I'm pretty sure we can do it with everything. It's just a matter of training. That's why when we partnered with the Linux Foundation at O'Reilly, we brought a lot of content on strangler pattern. That's very important. So hopefully that helps. So George was saying, I'm 100% for the transparency of the code and collaboration. DevSecOps is the way. However, what are your thoughts on putting all this information out there and allowing our adversary to come through and potentially finding areas of weakness? Yep, it's a tough line, right? And we did not put all of it, just to be clear. We did put 85%, but that's not all of it. But I still get your point. It's kind of a debate, but my take was DoD will not succeed if we don't have broad defense industrial base adoption, right? So if we don't get the DIB to join in the fight, we will not be able to succeed. And so if it's closed source or if it's proprietary or IP, people are not going to consume. I don't think I would have convinced Lockheed or Northrop or Raytheon and others to use Platform One, Big Bang on their, including Lockheed committing to doing it for all of Lockheed if it was an open source and the way we did it. So in one sense, by doing that, we expand adoption, and we got 150 free contributors that can push code at no cost to the US government back to Platform One, both, the UK MOD, Australian MOD, and different nations, and all the way to companies that do nothing with DoD contributing back. And so it's a kind of a two-way street that would never have existed without this, and a much broader adoption that nothing I've seen before. But at the same time, you have the downside of, China can see it, right? The goal was to make it commodity so people could consume it, but by making it commodity so contractors can consume it, so can China. And, just like Tesla was open to give away all the patents because they were moving so fast, they were hoping that no one would catch up to them. And the goal was to move fast. My take was we needed the DIB to be part of this, and we had to take the bet of giving it. We could have done it in a half-baked close thing, but it doesn't spread. Every time we try to do that behind Nipper and Dodin and all that nonsense, we just know that no one adopts it, right? And more importantly, it becomes kind of a fork DoD nonsense stuff, which is really anti-open source. And my goal was to contribute back to CNCF and open source projects. So I just felt like that was the right thing to do, but I guess time will tell, right? So yeah. So I think that was the last question.
That's the last one in the chat here. We've got like 2 minutes left. Maybe time for one more question if somebody wants to type one in fast or come off of mute. Give just a second here. I'm getting a lot of comments in the chat directly to me, Nick, complimenting you, saying what, really great talk, and thanking me for bringing you on. So I really appreciate you sharing with everybody.
Of course.
All right, if we don't have any more, everyone, we will have this recording up early next week. I want to thank everyone again for attending. Nick, especially a huge thank you to you for leading today's talk. Always a pleasure to be with you here online. Hopefully we can be together in person here sometime soon.
Yes.
And a final thank you to our corporate sponsor, Incredibuild, as well for supporting this community. Have a great rest of your day, everyone. It's almost the weekend. I hope to see everyone at the next one of these. And like I said, hopefully one of these things in person here sometime soon.
Thanks, everybody. Stay safe.
Thanks, everyone. Thank you, Nick.